Hi, in this video we will solve question number 9 from GATE 2020 chemistry paper. Now the question is the following. Which is the correct statement about the hexagonal boron nitride? And the four options are given here. Option A says it is a good electrical conductor. Option B, it has same layer stacking as that of the graphite. Option C, it is reactive towards fluorine. And option D, it has lower thermal stability in air compared to that of the graphite. Now before answering this, let's first look at the properties and structure of hexagonal boron nitride. Now in this slide we are comparing the layer structure between hexagonal boron nitride and the graphite. Now boron nitride form hexagonal sheets which are similar to that of the graphite, but the layer structure is somewhat different. In hexagonal boron nitride, the atoms in different layers directly lie above one another. That means each boron atom in each layer is having a nitrogen atom above or below it exactly. But in graphite, the layers are arranged in alternate orders. That means atoms on the adjoining layer are not directly above one another. Now let's look at this picture. This is the picture of layered structure of hexagonal boron nitride and the graphite. This is the structure for the hexagonal boron nitride sheet and this is the structure for the graphite sheet. Now if you look closely, in hexagonal boron nitride structure, the atoms in each layer are directly above one another. Now if you look close enough, this is nitrogen atom. So nitrogen atom in second layer having a boron atom above or below it, and other atoms in the second layer are exactly lie above one another. But in the graphite layer structure, you can see that the layers are arranged in alternate order. That means every third layer, that means suppose this is first layer, this is second layer, this is third layer. So every third layer is identical to the first layer. So and also the atoms are not directly lie above one another. So this is the fundamental difference between the layer structure of hexagonal boron nitride and the graphite. So the option B, which is it has same layer stacking as that of the graphite, is incorrect. Now, in hexagonal boron nitride, there are no delocalized electrons because nitrogen atom and the boron atom have electronegativity difference. That means nitrogen is more electronegative than the boron atom. So the electrons are the lone pair of nitrogen atoms. The electrons are mostly located or localized on the nitrogen atoms. It is not fully delocalized compared to that of the graphite. Whereas in graphite, the electrons are fully delocalized through the delocalized pi bonds, because graphite consists of carbon atom and there is no electronegativity difference here. That means the pi orbital or p orbital of each carbon atom form a delocalized pi bonds here along the hexagonal sheet. So electrons can fully go through from one another to another, for one end to another end without any barrier. So that's why the hexagonal boron nitride doesn't conduct electricity like graphite. It is an insulator. That means the option A, it is a good electrical conductor, is not correct. Now hexagonal boron nitride is also polar because of the electronegativity difference between the nitrogen and the boron atom. The hexagonal boron nitride can act as a lubricant like that of the graphite because there is a weak van der Waals forces between the two layers. So that's why the hexagonal boron nitride can also act as a lubricant as that of the graphite. But the hexagonal boron nitride is decomposed by water, fluorine and HF. And the reaction is the boron nitride. This is the Bn means the boron nitride. Here in this case it is hexagonal boron nitride. it reacts with the fluorine, then it forms boron difluoride BF3 molecule, and nitrogen gas. So in presence of fluorine, the hexagonal boron nitride decomposes into BF3 and nitrogen. So the option C, the hexagonal boron nitride is reactive towards fluorine, is correct. Now look at the option D. It has lower thermal stability in air compared to that of the graphite, is also not correct because the hexagonal boron nitride is also thermally stable. So among the four options, the option C, it is reactive towards fluorine, is the correct answer. Thank you.